Hello and welcome again to another exciting presentation. This presentation today is going to be a data science presentation from WBS Coding School, just to show you again exactly what is possible after a 15-week bootcamp at WBS Coding School. And right here with me in the studio, I have Anton and Samuel. Thank you so much for being here today. I'm excited to see your project. So instead of us getting into too much small talk, let's jump straight into this and show us what you've created over the last 15 weeks.
Good afternoon, everyone. My name is Anton and this is Samuel, and we present you our project Pictureminator. That guy in the picture is me, about 35 years ago. I think somewhere there is a photo album with 20 or 30 pictures of me growing up. And this wonderful boy's name is Mark, and he is my youngest son. He is only 5 years old, but I already have more photos of Mark than my grandmother had in her entire life. We live in an age of endless digital photos that are always with us, from phone snapshots and professional photo shoots to screenshots taken during a conference call and scans of documents. We created Pictureminator so that everyone can organize their digital archive without resorting to cloud computing and third parties.
What we want to create. Our main idea was to create a mechanism that would help highlight similar photos, categorize them, and simply put, to bring order among the huge volume of photos. I have over 7,800 pictures in my phone, and an increased amount are duplicates. In our work, we use the principle of machine learning. To connect the algorithms, we initially extract over 50 features from each photo and label the groups manually into a data table. After that, we create separate models to proceed with new features. For each method, we created our perfect model and used only those features that fit it. After extracting the features, which are the characteristics of each image, the program sorts first all the videos and then the incoming images for classifications, screenshots, and then documents. In the case of similar photos, such as those that were taken just a few seconds apart, the model analyzes their characteristics and sorts them. The best pictures go into the right folder, the other ones are kept into the duplicates folder. In the continuing process are identified images that are blurry, shaken, or even pictures with people that have the eyes closed, a function that is very useful with group photos. Another characteristic that our program has is to identify professional and high-quality pictures and move them into the everyday watching folder called Super. After finishing the classification, my 7,800 pictures were sorted into 7 folders. 3 folders for view and delete, 3 folders to keep, and one to decide personally what to do with them. Of course, I can keep them all because nothing will be deleted, but the need for space for the new ones spread my memory from almost half of the pictures.
Under the hood of our program is the sklearn machine learning library, the Python programming language, and more than 3,000 manually selected photos from personal archives, totaling more than 6 gigabytes. We wrote about 4,000 lines of code and improved our project a lot. For example, when we first launched it, it took about 8 hours to process 1,000 photos, and now we do it in 10 minutes. So, now let's look at a few examples of how the algorithm works. Miguel, maybe try taking on the role of AI and tell me which one is better.
Okay, wow. I think the second one on the right is better in my mind.
The right one, of course, yes. The right one is better. It is a little bit sharper and there is no anyone in the background, and the algorithm chosen the right one. Now, try to guess here.
I think the first one is the better one of the two. on the left-hand side?
The one on the left is better. It's clearer and the man is smiling here. And now we have a bigger challenge because they are practically identical.
Wow, this is a really good one. On the right-hand side, I would say that is the better picture.
Pictureminator favors the right image too. And now, if you have chosen another picture in the previous step, now maybe you should change your opinion because you actually think that now the right one is better. So, in conclusion, I want to say that of course our program is not perfect. We can't train it on all photos of the world. That's why it can sometimes make mistakes. That's why we only put photos in folders and give you the option to delete them yourself. And of course, the price for searching for similar photos is the comparison of sometimes completely different photos. But despite this, if you want to put your gallery in order, our program will save you dozens of hours. We don't plan to stop. Our project is already available to everyone in the repository on GitHub, and anyone can not only use it but also help in its development. So, we invite you to become one of the first Pictureminator users. Now I want to say thank you for your attention and we are ready to answer your questions.
Wow, that's so great. I definitely think that this is such a useful tool, and it's actually amazing that, after this bootcamp of 15 weeks that you have created this incredible software that is useful in everyday life. And I think sometimes people kind of miss the fact that this is real data science. This is what it is, So from my side, I just want to say congratulations. This is mind-blowing. And this is definitely a type of software that I will make use of. And I want to wish the both of you all the best and good luck for the future as you go from WBS Coding School into a new career and on a new career path with a new journey. It's a big world out there, but it's an exciting one, and well done with these skills.
Thank you for your support and for your words also.